All right, students, so we're going to do a video on linear growth models. This Calvin and Hobbes cartoon has nothing really to do with linear growth, but it has something to do with math, so I figured I'd throw it on there, change it up a bit. Anyway, pause the video if you want to check it out. It's pretty good. All right, so what is linear growth? Here's an example of a problem. There are 3,500 students attending a local community college, and the number of students is increasing by 125 each year. How many students will attend the college in 4 years? And when will the number of students reach 5,600? So let's look at this problem. Suppose that p to the n, and that's this p down, this little number down here, this letter, represents actually the number of years. So p represents the number of students, and n represents the number of years. So P0 would be the number of students at time 0. P1 would represent the number of students after 1 year, and P2 would represent the number of students after 2 years, and so on. So at P0, we have 3,500 students. And at Pn, we would have the previous number of students plus 125, and this is known as a recursive function. It's based off of the previous number. So at P0, we would plug in 30. So P1, you would plug in P1 here, and then this would, n minus 1 would be 1 minus 0, which would be P0, which is 3,500. So at P1, you would have 3,500 plus 125. So here's an example, right? So at P1, it's P0 plus 125, you get 3,625. And so if we want to figure out, what did we want? We wanted, when will it be 5,600 students? Well, here, after 4 years, we found out that there would be 4,000 students. So when would there be 5,600? Why don't you see if you can pause the video and see if you can figure that out. So did you figure it out? Well, let's take a look in a second. I'm not going to reveal the answer yet. So this is how these recursive functions work, right? So it's p to sub n equals p to the n minus 1 plus 125. And if p0 is 3,500, we're just going to add 125 each time, right? So p sub 2 is 3,500 plus 125, which is p plus p sub 1. And you're just going to continue down this ladder and keep adding 125 each time. So what we really want is the general form for this, because solving something like what we're just trying to figure out takes a while to figure out using recursive functions like what is 5,600. So let's look at p sub 3, right? So p sub 3 really is the 3,500 plus 3 times 125. Notice where the 3 comes in. It's right there. So, and here, this is 3,500 plus 2 times 125. Notice this is p sub 2. P sub 1. P sub 0. So the general form for this is just this, right? It's just p to the n equals p sub 0 plus n times 125, the number of years times 125. So we can use that to figure out when it was 5,600, and let's take a look. So here it is. So we know p sub n has to be 5,600, then we can just set up the equation, right? So 5,600 equals 3,500 plus 125n. If we subtract 3,500 from both sides, you get 2,100 equals 125n. Divide both sides by 125, and you get n is approximately equal to, well, actually it is exactly equal to 16.8, approximately equal to 17, right? Because we need to round that up. So when do we actually reach 5,600? It's not till the 17th year. So that's when that college would have 5,600 students. So that is an example of a linear growth rate. And let's erase all of that. So this is what a linear growth would look like. It's just a straight line. It's just straight line growth. And this equation should look familiar to all of you. It is really just the linear form of an equation. Remember, y equals mx plus b. So we have recursive functions. So if a quantity starts at P0 and grows by this, whatever this D is every time period, and we're going to use D because that like kind of represents change, and if we think about the Greek letter delta, which is a triangle, that's really what we're going to talk about. So for those of you who have taken calculus, that might be familiar to you. So D every time period, then the quantity after n time periods can be determined using either of these relationships. The recursive function, which is P sub n equals P sub n minus 1 plus this rate of change, and in this case it's a linear growth rate. And then this general form, which is P sub n, sometimes it's called an explicit form, P sub n equals P sub 0 plus this rate of change times n. And this looks really familiar, right? This is basically our y-intercept, and this is our slope. So D represents the rate of change, or the linear growth rate. So take a look at this problem. We have both the recursive form and the general or explicit form, and see if you can solve this problem. The city has 128 streetlights. As part of an urban renewal program, the City Council has decided to install 3 additional streetlights at the end of each week and for the next 52 weeks. Write the recursive and explicit formulas to represent this linear growth. And then the second part, which I'm not going to reveal this answer until you try it, is how many streetlights will the city have at the end of 42 weeks? So here is the recursive form. And here's the general form. So P sub n equals P sub n minus 1 plus 3, where P sub 0 equals 128, and then here's our general form. So try this problem down here, and please let me know if you have any questions. Thanks for watching.